Hello and welcome. In this video, we're going to be going through another Mechanics 1 tough question. This question is from the Jan 2022 and it's a vectors question, and lots of people get confused with these style of questions. So today we're going to attempt to solve this, and I'm going to show you how you can answer and approach these types of questions. So let's start by reading the question. It tells me that in this question, I and j are horizontal unit vectors directed due east and north respectively. So it's just telling me that my I is a unit vector, which is a vector with a magnitude of 1 pointing to the east, and j is a unit vector pointing to the north. Okay? So it says ship A moves with constant velocity 3i minus 10j kilometers per hour. At time t hours, the position vector of A is r kilometers. Like, what is a position vector? If we start by drawing our plane, let's say this is ship A. A is not still, it's moving. So let's say that this is at t equals 0 seconds. So this is the initial position of A. Now let's say A is moving with this velocity vector. So after 1 second, A is going to be over here. After another second, A is going to be over there. So position vector is this green vector. The position vector is the vector that tells me where is the position of A relative to the origin. So at time t equals 0, this was the position vector of A. At time t equals 1, this was the position vector of A. And at time t equals 3, for example, this was the position vector of A. So we can see that the position vector is depending on time. So it's a function of time. So I'm going to give you the general way to write a position vector of anything, or the formula for position vector. Let's say position vector P is going to equal P0, which is the position vector at t equals 0, or is equal to the initial position vector, plus the velocity of my object multiply the time. This time is going to remain as t, where when I replace any value of t, let's say I want to get the position vector at t equals 1 second. So I'm going to put in t over here, and I'm going to compute this, and it's going to give me the position vector at t equals 1. So this is basically how we can find the general equation of a position vector. So returning to this question, it tells me that at time t equals hour, the position vector of A is called r. So this is the general position vector of A. It's called r. And it tells me that at time t equals 0, A is at a point with a position vector of 13i plus 5j. At time t equals 0, this is the position of A. So this is basically r0, right? So from our formula, the position vector is going to equal the initial position vector plus the velocity vector multiply time. So now, to find r in terms of t, let's compute this and substitute everything inside. So r is going to equal, r0 was 13i plus 5j plus velocity vector. What's the velocity vector? It's 3i minus 10j, and then multiplied by time. This is going to be r in terms of t. And I like to write it in this way. You're free to do so. Is if you multiply this t inside, this is going to be 3ti minus 10tj. So I like to group the i's together. So the I is going to be 13 plus 3 times t. This is going to be the I component, and then we'll do the same for the j. So the j is going to be the 5 minus the 10 multiply the t, so minus 10t in the j. So this are two ways to write the position vector. Two are accepted. It's just a matter of preference. Right. So this is part A. Now let's try and solve part B over here. Okay. So part B tells me there is another ship moving with another constant velocity. By the way, you can only use this, okay, when the velocity is constant. You can use this or this when the velocity is constant. So it tells me that another ship B moves with a constant velocity, this vector. At time t equals 0, B is at this positions. So this is basically the let's call the position vector b, let's call it small b. So this is going to be b0, and this is going to be velocity of b. Yeah, it says show that at time t hours AB is this. Right. First of all, what is AB? The vector AB. The vector AB denotes the displacement between A and B, and is equal to the general vector of B minus the general vector of A, which was R. So the general vector of A, which is R, we already have it. We just need to compute what is the general position vector B. So again, since it's a constant velocity, we can use this formula over here. So B is going to equal B0 plus VT. Yeah? So B is going to equal, what is B0? It's basically 3I minus 5J plus velocity, which is 15I plus 14J into time, which is T. Okay? Again, if I want to write it in this exact form, I'm going to group the i's together. So I'm going to group the i's together. So B is going to equal 3 plus 15t. So 3 plus 15t in the I component plus the negative 5 plus a 14 times t in the j component. And this is going to be my general position vector for B. Okay? So now we have both, we have B and we have R. Now we can subtract them from each other to get AB. So we can do that. Let's copy this position vector and paste it over here. Yeah. So we want AB. So AB is going to equal B minus R. Yeah. So B minus R. You can see that B minus R means that you take the I components, subtract them from each other, and the J components, subtract them from each other. So we can see that in the I, we're going to have 3 plus 15t minus 13 plus 3t. This is going to be the I component. And then we do the same for the J component. We will have a minus 5 plus 14t minus 5 minus 10t in the J. So computing this, we're going to have a 3 minus 13. That is going to give me a negative 10. And I'm going to have a 5 minus 3 is going to give me a plus 12t. This is in the I component. Plus, we do the same for the J. We're going to have a minus 5 minus 5. So this is going to be minus 10. And then we have 14 minus negative 10. So it's the same as 14 plus 10. So 14 plus 10 is 24t in the J. And this is our A, B vector over here. Let's copy it and compare it to see if this is the same as what we were supposed to show. So in the I, we have a minus 10. We have the minus 10. Plus 12t, we have a plus 12t. That is the I component. So till now we are correct. Over to the J, we have the 24t minus 10 minus 10j. You can write them interchangeably. There is no any issues. So we know that this is the correct answer. Now, for part C, where students always get confused, it tells me find the shortest distance between the two ships. AB is not distance. AB is displacement. Is the vector. Okay? Is a displacement vector. Okay? So how do we go from displacement to distance? We get the magnitude. So square root of x squared plus y squared. X here is the I component and y is the j component. So let's do that. So the distance, let's call it d, is going to equal, let's call it d, okay, is going to equal a big square root of the I component squared. So the I component was minus 10 plus 12t all to the power of 2 plus the j component, which is minus 10 plus 24t all squared. Now, let's simplify this. So this is going to be square root of negative 10 squared is 100. And then first times second times 2. So negative 10 times 12 is negative 120t times 2 is negative 240t. And then 12t squared is going to become 144t squared. Then adding to that, the second bracket, negative 10 squared is going to be 100 plus, actually not plus, we have the first term times the second term times 2. So negative 10 times 24t, that is negative 240t, times 2, that is negative 480t. And then plus 24t squared, this is going to be 24 squared is 576. And then we have the t squared. So simplifying, we're going to have, let's start with the t squared terms first. So we have 144 plus 576. That's going to be 720 t squared. And then we have, let's do the t term first. We have negative 240 minus 480. That is going to give me minus 720t. And then we have 100 plus 100. That is going to be plus 200. This is my distance. So if I want the distance at any specific time, I just compute the time in there, just substitute the time into there and solve it on the calculator. Is going to give me the distance at that time. The question asks for the shortest distance or the minimum distance. Whenever we check or see the word minimum, what do we think? We think about differentiation, or we think about minimum or maximum. That's when we think about the critical points. We think about differentiation. So to get the minimum distance, obviously you're not going to keep on trying different times and see which distance is the shortest, right? So to do this, we need this whole thing to be a minimum. The whole thing that's under the square root to be a minimum, right? So why don't we differentiate what's under the square root? Okay, so let's call what's under the square root, let's call it anything. Let's call it big S. Let's call it 720t squared minus 720t plus 200. And let's get the differentiation of ds by dt. That is going to be 720 times 2, because it's power times coefficient, is going to be 1440, and then reduce the power by 1. Negative 720t, the differentiation of that is going to be minus 720, and then 200 is going to become 0. Now I got the differentiation. Okay, how do I get the minimum? I know that the minimum or maximum points always occur when the differentiation is equated to 0, right? So I will equate my derivative. This is t minus 720 equal 0, and I'm going to find the time that makes this happen. So 1440 equals 720. There's a t here. So to find t, we divide 1440, divide 1440. So the time is going to equal, is going to give me 0.5 seconds. So 0.5 seconds is a critical value of this expression over here. It might be a minimum, it might be a maximum. To double check, and by the way, I've done a complete course on mechanics. Please feel free to go check it. I'm going to leave a link on the top right hand corner. It's super helpful. It's basically designed to give you everything you need to know for the mechanics test. I went through the same exact test, and I've gathered all the information and summaries and keywords and everything, and I formulated a course on Udemy for you that is going to be a replacement for all your expensive, inconvenient tuitions. Please feel free to go check it, and if you're interested, let me know down in the comments or email me, and I'm going to send you a discount code. Feel free to check it out. So this course, the reason I said about the course is because this course addresses this importance. It addresses how to use calculus in mechanics, differentiation in vectors and all of these things, and I go super in detail in that course. So anyways, to test if this point, if this t is going to be a minimum or a maximum, we need to use the second derivative. We agreed that this is already a critical point. It's just a matter of fact, is it a minimum critical or a maximum critical? So to do that, we need to get the second derivative, ds by dt squared, which is basically differentiating the first derivative again. So this is just going to give me 1440. And the rule tells me that I will substitute my x or my t that I'm trying to test, if minimum or maximum. I'm gonna substitute it inside the second derivative. If the answer is positive, then it's a minimum. The answer is negative, then it's a maximum. However, here I don't have any t to substitute, so I'm just going to take this as the answer always for the second derivative. So the second derivative is always positive, and we said that when it's positive, it means that my my critical points are minimum critical points. So this tells me that at t equals 0.5 is going to be a minimum value. So let's return back to the distance. Now we know that at t equals 0.5, the distance is minimum. So what we do, very simply, we just substitute 0.5 into this expression over here to become, let's actually copy it over here. So let's write it over here. So square root of 720 times 0.5 squared minus 720 times 0.5 plus 200. This is going to give me my distance, which is going to be calculated as I got root of 20, which is equal to around 4.5, and the unit here is kilometers. Never forget your units to not lose marks. So this is basically the minimum distance that they will be near each other. There will not be at any time any distance lower than this for the distance between A and B. So now, last part, which is D, says find the bearing of ship B from the bearing of ship A when the ships are closest. So bearings, what I need, actually I can use this. So bearings, to find the bearing of something from something else, I need to know where is the position of the first thing, where is the position of the other thing, and then I will see the angle between them in a special way called bearings, and I'll teach you how to do it. So it tells me find the bearing at which time, when the ships are closest, and I know they are closest at which time, 0.5 seconds. So I already calculated that. So if you remember, the position vectors, which are B and R, they're going to help us here in getting the actual positions relative to the origin of both ships. So R was ship A and this was ship B. So it was 13 plus 3t. I don't know why this was not copied in the I. So at, let's say, at 0.5 seconds, at t equals 0.5 seconds, A is going to be at, we are going to use this to find the position of A. So we're going to substitute 0.5 on every single t over here. It's going to be 13 plus 0.5 times 3. Actually, let me write it. 0.5 times 3 in the I, plus 5 minus 10 times 0.5 in the j. So this is going to equal 13 plus 3 times 0.5, that's 1.5, plus 13, that's 14.5 in the I, plus 5 minus 10 times 0.5 is 5, so 5 minus 5 is going to be 0 in the j, so basically it's just 14.5 in the I, and that is A over here. Let's do the same for B. Let's do it over here. So B, we're going to have 3 plus 15 into 0.5 in the I, plus negative 5 plus 14 into 0.5 in the j. So this is going to equal 3 plus 15 times 0.5 is 7.5, plus 3, that is 10.5 in the I, plus, okay, 14 times 0.5, that is 7, negative 5 plus 7 is basically 2, just 2. So 2 in the J. So now, these are the two vectors, or are the two position vectors, okay, that the ships are at this exact time, at 0.5 seconds. These are the positions of the two ships. Let's put it over here. So this one is A, this one is B. So let's draw on our coordinate system where is A and where is B. So I can see that A is 14.5 in the I direction. I know that this is in the I, this is the J direction. So I'm going to move 14.5 in the I direction. This is going to be the position of A. It doesn't have any J components, so it's literally just on the I. For B, it's going to be 10.5 in the I and 2 in the J. So B is going to be over here. That is B. So this is 10.5. This is 14.5. And this is 2. Okay. So now the question tells me find the bearing of ship B from A. So if I want the bearing of ship B from A, so from A tells me straight away that I will need to draw a north at A. I'll call it the north. It's just a line pointing to the north. And this line connects B to A. What I need to do bearing is I always move clockwise. I always move clockwise. So I'll always move clockwise until I hit the line that's connecting my 2 points, B and A. So I always, if it's asking for bearing from A, I will draw my north at A, and then from the north move clockwise until I hit the line which connects my 2 points. So basically this whole angle is going to give me the bearing. So to find this angle, I can see that if I found this small angle, let's call it theta, okay, I can add it to, I know that this is 270, so I can add it to 270 to get this whole angle. So let's try and get theta. First of all, if this whole thing is 14.5 and this is 10.5, it means that this green bit is going to be 14.5 minus 10.5, that is 4. And I know that this bit is 2. So theta, super easily, I can say that tan theta equals opposite over adjacent, so 2 over 4. If I want to get theta, that's going to equal tan inverse of 2 over 4. And this is going to give me an answer of around, let's check, so shift tan, 26.57. So 26.57 degrees. So if I want the bearing, is going to equal 270 plus the 26.57. That is going to give me an answer of 296.5. So let me round it just to the nearest whole number. Always round it to the nearest whole number in bearings. So it's just going to be 297 degrees. And this whole angle is 297. This is my bearing to answer part D. I hope this was helpful. I hope that if you have any questions, you can send them on email or comment them down below. I'm going to look at all of them. I'm going to try to answer all of you. Thank you so much for watching. Please don't forget to like and subscribe. Leave a comment. Give me feedback and suggestions. Anyways, thank you for your time. Have a great day.